For the beam loaded as shown by double integration method, determine the slope and deflection at points B and C. EA is constant. So here is the given beam. Let's call the reactions at AY vertical. The horizontal reaction is 0 but not shown. So let's section this last part, CD. But before that, let's solve for AY. So set moment D0 or summation moment D0. So AY times 10 minus 20 times 8 minus 30 times 5. So AY is equal to 31 kilonewtons. Then we set moment equation in portion CD. EIY double prime equals 31 times x, then minus 20 times this distance is quantity x minus 2, then minus 30 times this moment arm x minus 5. So that's the differential equation of the elastic curve. Then integrating once, EIY prime equals 15.5 x squared, 31 x squared over 2 or 15.5 x squared. So this is minus 10 x minus 2 square or 20 over 2. Then minus 15 x minus 5 quantity square. Then plus c sub 1, the constant of integration. That's the slope of the elastic curve at any point. Then integrating again, EIY is 15.5 x cubed over 3 or 31 over 6 x cubed. Then minus 10 thirds quantity x minus 2 cubed. Then minus 15 over 3 or 5 quantity x minus 5 cubed plus c sub 1x. Then plus supposedly c sub 2, but because A is the origin, it is a support, so no settlement, then c sub 2 is 0, so plus c sub 1x only. That's the deflection. We now evaluate the value of c sub 1 by setting the value of x in this equation, 10, boundary condition. When x is 10, it is a support, so y is 0. So 0 equals 31 over 6 10 cubed minus 10 thirds 8 cubed, 10 minus 2 is 8, minus 5 times 5 cubed plus c sub 1 times 10. Solving for c sub 1 using your calculator there. So c sub 1 is equal to negative 283.5. This c sub 1 divided by EI is the slope at A. So that's the geometric interpretation. So let's have that so that you will be accustomed to interpreting c sub 1 and c sub 2 when the method used is double integration, so that you will be equipped with the principles. Then we solve for slope at B. In this equation here, we set x is 2 when at B. So EI theta B equals 15.5 2 square. This is 0. This is negative, so we just ignore. So plus c sub 1. Plus c sub 1, which is negative 283.5. So from there, we can solve theta B equals negative 221.5 over EI. Then x is 2 for the deflection. So EI delta B equals 31 over 6 2 cubed in this equation here. Second term is 0. Third term, the quantity inside the parenthesis is negative, so we just ignore that. Then plus negative 283.5 times 2. So delta B is equal to negative 525.67 over EI. Then when at C, x is 5 for slope here, EI theta C is equal to 15.55 square. The second term can now be used, negative 10, 5 minus 2 is 3, so negative 10 times 3 square. Then here, this is 0, then plus negative 283.5 c sub 1. So theta C is equal to 14 over EI. Then plus d for the deflection into this equation here. X is 5. EI delta C is equal to 31 over 6 5 cube minus 10 thirds 3 cube, and this is 0, then plus negative 283.5 times 5. So delta C is equal to negative 861.67 over EI. So that's it for this problem, and this is a simple one. I hope that you were able to follow the solution.